Hi, my name is Scott Dennehy, and I am doing my term project for AIT 381 on video signal basics. Video signal basics basically covers the 5 different types of video signals that are available currently to users. So sit back and enjoy this short presentation on video signal basics. There are several types of video signals. The 5 types of signals that we'll cover here are composite video, S video, component analog video, high definition video, and digital video. Video signals come in many different flavors due to several factors. These factors could be different functional requirements, changing limits of technology, or different developmental areas. These factors have combined to create many types of video signals, with each having its own benefits and drawbacks. Composite video. Composite video signal contains all of the information required to form a full motion, colorful image on a television screen. Several different composite color video standards are used around the world. NTSC video is used in North and Central America, Japan, South Korea, Taiwan, and most portions of South America. Video signals using this standard contain 525 horizontal lines that are each transmitted 29.97 times per second and use a 3.5 MHz color carrier frequency. PAL video is used in most countries in Europe and many in Africa and the Middle East. Video signals using this standard contain 625 horizontal lines and are each transmitted 25 times per second and use a 4.3 MHz color carrier frequency. CCAM video is used in France, countries in the former Soviet Union, North Africa, and numbers of countries. Like PAL, CCAM videos contain 625 horizontal lines and are each transmitted 25 times per second. The main difference here is between the method of transmitting the chroma signals. Some advantages and disadvantages of composite video are advantages are huge numbers of display devices available throughout the world, low-cost signal sources and recorders such as VCRs. Some disadvantages are the chroma and luma signals can interfere with each other, causing some degradation in the display image. S-video. S-video signals are similar to composite video signals with one crucial difference. In S-video, luma and chroma information are carried on different wires. This is why an S-video cable has 4 pins, one pair for the chroma signal and the other pair for the luma. S-video can be found on a number of consumer video devices, including many recent television receivers, DVD players, digital camcorders, and high-end VCRs. Some advantages and disadvantages. Advantages of S-video are many modern consumer devices have S-video inputs and/or outputs. Separated chromance and luminance signals can give better picture quality. Some disadvantages of S-video are cabling and connectors are slightly more complicated than that of composite video. Video switches require 2 signal paths for each video signal. S-video format is still closely related to composite, so wide varieties of video standards, NTSC, PAL, etc., still need to be accommodated. Component analog video. Component analog video offers benefits over composite and S-video due to the fact that the signals are carried over different sets of conductors and processing is kept to a minimum. There are 2 types of component video, RGB and YUV. RGB component video uses one conductor for each of the 3 main video component signals, red, green, and blue. Each signal carries a full resolution image with data for every pixel. YUV component video signals use 3 signal paths, one for the luminance signal and the other 2 for each color difference signals. Both RGB and YUV signals require 3 or more signal paths, depending on the method chosen for sending the synchronization signals. 3 main standards exist. Sync on green. Sync on green requires 3 signal paths. This method uses one of the 3 signals, typically the green signal or the Y signal, to carry the horizontal and vertical synchronization. Separate composite sync uses a 4th signal path to carry the synchronization data, including both the horizontal and the vertical synchronization. Separate horizontal and vertical sync uses a total of 5 signal paths, one for each color signal, one for horizontal, and one for vertical. This system is used in virtually all computer monitors and is part of the original VGA de facto standard. There are several advantages and disadvantages for component analog video. The advantages are the highest possible quality analog video. It's suitable for editing and post-production use for professional applications. Some disadvantages are that it requires more cables, up to 5 for separate vertical and horizontal sync, thereby making it cables and switches more complex and expensive. Delay in each one of the signal paths must be identical to all the others. If one cable is longer or shorter than the others, then the objects can display ghosts or color fringes on the screen. High definition and digital video. High definition video offers more detail in video images. It uses a different aspect ratio, 16.9 versus 4.3. It does have no benefit to the small screen user, but it also comes at a price in terms of both money and technology. AIT signals tend to be large and very costly, and from a technology standpoint, the large number of pixels requires much more detail in the signal. This in turn causes the bandwidth of the signal to increase, making it impossible to send an HDT signal in the same amount of spectrum as a standard definition signal. Some advantages are much more image detail, like we said, with many more pixels on display. Some versions are suitable for use in creating cinema films. Some disadvantages are it requires AIT compatible equipment throughout the production chain, including the cameras, the videotape, the broadcast equipment, and the video displays. HDTV also uses compression to permit broadcasting within existing television broadcast channels, which can add considerable expense for both broadcaster and end user customer. The digital video is minor noise and distortions have no impact on digital signals. The most common types are SDI or serial digital interface, and there is also a high definition signal called an HDSI. It's used as a standardized input for MPEG compression devices, and it has several advantages and disadvantages. The advantages of SDI video are it's a very robust signal, small variations in signal amplitude or noise, and can be ignored by the digital format. It's easy to transport and switch inside a production facility. Many converters are available for handling the changes to and from SDI and composite, and related signals such as digital audio or program-related data can be embedded into an SDI signal for easy transport and switching. Some disadvantages are that it requires an SDI-compatible equipment on both ends of each connection. Much of the equipment that handles SDI is considered professional level and can be expensive, and the high bit rate signals can be difficult and expensive to transport over wide area networks. Well, there you have it. I hope that you've enjoyed this brief overview of the types of video signals that are available. Again, there are many different reasons why we have so many different video signals, from different functional requirements, meaning from video being stored in its highest level to having it being a low quality level for distribution to the masses. Also changing limits in technology, stuff that was conceivable that's conceivable now was not even conceivable 5 years ago, and different developmental locations also have to do with the number of video signals available. Different locations had different types of video development, so therefore you see different video signals. I hope that you've enjoyed this brief overview as much as I have enjoyed making it.